Howdy folks, we are now going to look at the next example, next part of example 4, which was finding all the real and imaginary zeros for the polynomial function. So just like with the previous part A, we first want to get a list of possible rational zeros. So let's do our P's and Q's just like from before. So P in this case is based off of the constant. So factors of 15, so plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. And then for Q would be factors of the leading coefficient, so 8, so plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So now we have to put our P's and Q's together. So remember, the first is just to put it all over the 1, which is the first factor of 8. So we'll get all of our P. And again, we're not going to put them in numerical order, but so now we can put each of these over the 2, so plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and 15/2. And then the 4, so plus or minus 1/4, 3/4, 5/4, and 15/4, and then of course we still got the 8. So plus or minus 1/8, 3/8, 5/8, and 15/8. So again, we got a really huge list of numbers to check. Now, like I said, obviously a graphing utility will help us narrow down the field quite a bit. So obviously you can do that, but I would try to encourage you to try not to do that until you at least give it a shot, see if you get lucky. Again, you might find a number that works pretty quickly in this. So, well, we can start anywhere we want. Let's start with the 3. You know, as a rule of thumb, where should you start? I mean, do you want to start with the very first one and go, yes, you can do that. Personally, we're going to see that it's going to be better if you start in the middle of the pack. If you start in the middle of the pack, then there's going to be some tricks we're going to see of how we can whittle down the list really quickly. So I would start in the middle. So I'm going to start with 3. That's, you know, we got a lot of fractional answers. So 3 is kind of a bigger one in the big scheme of things. So let's try 3. So we have all of our coefficients. So 8. So 24, so a negative 12, so a negative 36, and then we got a 10, 30, and we got 15. So 3 is no good. Now we could try negative 3 and see if that works too. You know, there's all the positives and the negatives that we technically should check. Now this, again, obviously is very time consuming, and you know, you're gonna, wow, we got some big numbers here. Well, we can kind of see based off of just that little bit, you know, we're getting some really large numbers. Is this going to give us a 0 at the end? No, you really don't even need to finish it to see that it's not going to work. So let's see if we can narrow down the field a little bit. So I went through and I graphed it on my smartphone here. Let me just bring down the brighten this a little bit so you can see it. So there's the graph of it. So we can see that we do have positive zeros here, and we can kind of make out that, well, it looks like possibly 1/2, and possibly 1.5, and possibly 2.5 might be zeros for our polynomial. So let's try one of those. Let's try maybe the 5/2. See if that works. So bring down our 8 and multiply. So we got 40/2, which is 20. So negative 16. So 80/2, which is 40. So negative 40. And bring down the 6. So 30/2, which is 15, and it's positive 15. And lo and behold, we do get a 0. Yay! All right, so now we can, since it's again, it's a third degree polynomial, and once you find 1 0, we don't have to do this anymore. We can use factoring methods and quadratic techniques to break it down. So let's do that. So we have x minus 5/2, and then we have the rest of it. So we got 8x squared minus 16x plus 6 equals 0. Well, how should we break this down? Well, first of all, one thing you should notice about this trinomial is that all of our coefficients are even. So we can actually pull out that factor of 2. Now, we're going to be able to take that 2 and apply it to the first factor, but let's just factor out first. So that's simplified down as really as much as we can do. But let's take this 2 and multiply it into this first factor. So the 2 is going to get multiplied by the x, which gives us 2x. And the 2 times the 5/2, well, the 2's will cancel, so that's just going to give us a minus 5. So if you don't like fractions, that's a nice little way to get rid of it. But only if you have that extra 2 that you can factor out. So this should be equivalent. So now we just have to break down this quadratic here, and we should be good to go. So let's see what we got. Now, we can't just automatically assume this is going to be a 2x and a 2x. Now, you might be thinking, well, wait a minute, we just looked at the graph. The graph was on halves, so we should be able to get halves, right? Well, let's just try a few scenarios just to make sure. If we did say we had a 4x and an x, would that possibly give us a possible factorization? So, we do get our 4x squared here, obviously, and so factors of 3 would have to be at the end. Plus, we know our little trick about the sign, so these are both going to have to be minuses. So, I mean, if we said a 3 and a 1, would that work? Well, we got a minus 12, and a minus 1 is a minus 13, so that's no good. If we swap this around, would that work? If this was a 3 and that was a 1. Well, there's a minus 3 and a minus 4, which is a minus 7x, not minus 8, so that's no good. And that's really the only possibilities when we have a 4x and an x. So let's get rid of that. So because we can't use that breakdown of 4x squared, we're going to have to use 2x and 2x. And again, the signs are still going to be both minuses. And because it doesn't really matter, we can put the 1 here and the 3 here, or vice versa. And we can see that it will work. So we got a minus 2x and a minus 6x, which gives us that minus 8x. So we're good. And now the last step, remember, is we don't want the factorization, we want the zeros. So go that last step now, set each of these equal to 0, and get your zeros. So we have 5 halves, 1 half, and 3 halves. So there's our zeros. Again, not the most fun way to do these problems, but if you didn't have a calculator, especially a graphing one, this is really all you have for options. You know, I mean, you could trial and error till the cows come home, but at least with this list, you have a starting point and see if you might get lucky. And we did, eventually. So, all right, well, let's stop there and we'll pick up the last part of this section in the next video. So stay tuned.